This is the HP7980XE tape drive that's on the HP3000 system that we're looking at. And this is a real tape drive that used magnetic tapes, like this one here. This was probably or I suspect it was the last half-inch tape drive that HP designed, manufactured, and marketed on actually any system. And this particular tape drive was used on 3000 systems, 1000 systems, and HP also sold it as an OEM platform, meaning that other companies would take this hardware and put their name on it and sell it under their own badge and so forth. So just real quickly, operator front panel here. Here's the door that we use to put the tape drive in. Some operator switches here. Usually this drive is inside a cabinet, and it can be pulled out like a drawer. But usually the only thing you'll see is this front panel here, so the rest of the unit is inside a cabinet. Compared to the 7974 that we saw, the tape actually is spooled horizontally instead of vertically like on the upright tape drives. This was done because one just took a lot more space and you could stack these drives on top of each other. And this also is an auto-loading tape drive, so there's no need for the operator to manually thread the tape. It used a airflow that we'll look at in a minute to thread the tape. And the other big difference between it and earlier models like the 7974 or 78 was that it's a streaming tape drive, in that earlier tape drives, when they would read or write the tape, they would start the tape moving, and then they would do the operation, and then the tape would stop after a moment. But then there would be a lag in getting the tape moving again before it could start reading or writing. With this tape drive here, what they always try and do is always have the tape moving, so it's streaming the data continuously, and we'll see how that kind of works. So there's a lot less start-stop on this drive, although it can operate in that mode. It's actually a little bit slower just because it's optimized for streaming and high performance. Just one other comment about it being an OEM drive. The nice thing about this being an OEM drive is there's a ton of hardware documentation on these drives. And again, you can get that from HP Computer Museum, or actually I got the CE manual and operator's manual, downloaded them from bitsavers.org. So just real quickly, again, reel tapes came in lots of different flavors. This is one that would hang on a rack using that little hook there. Usually have a label and a label on the outside, so when they're all hanging on a rack, you can see a number to identify the particular tape. A right ring would go in the back there, and different kinds of containers for the tape. This is an older canister type container. Just have a lid that snaps on like that, and we push a button, open it up. This is smaller tape. This is, I believe, a 600-foot tape. And then for large mainframe sites that had auto-load tape drives, one particular mechanism or way of doing those was to have this auto-load flange or container here, which many sites. This particular drive, even though it's auto-load, doesn't need one of those. So let's go ahead and power this on, load a tape. We're going to run some self-tests real quick, and then we'll go from there. Okay, so the on-off switch is right here. Let me just move this a little bit so we can see that. Push that, turn it on. First thing we see is the operator panel light up here. So it's starting to go through a self-test. And you can see a segment display showing how far it's completed on the self-test. It's exercising all the operator lights on the front. And it finished the self-test and said it's ready. And what it's going to do is it's going to assume there's a tape in the drive and just automatically try and load that tape. So we see here, we see this hub starting to spin. We don't have a tape in there, so after a minute it's going to realize, hey, there's nothing there. and it's going to stop it. What we're going to do is just hit reset and tell it to stop. So usually this is the state the drive would be in, just waiting for an operator to come up, mount a tape, and the way that an operator would do that is just hit the unload button here, and then that pops the door open, and the operator would stick the tape in there, and so forth. One other thing I want to show you before we actually do that is to open up this lid here, which just pops open. So this particular drive here, there's no way for an operator, or there is a way, but the normal operating procedure was for the tape to just be inserted and then the drive to automatically thread the tape, to minimize the amount of manual handling that an operator had to do on the tape, because again, stretching the tape or contaminating the tape was very bad and could lead to a lot of data errors. So a tape would go in through the drawer, and then this airstream would blow the tape around the tape path, and then it would get threaded on the take-up reel here, and there's a tensioning arm that can be used to vary the amount of tension that's on the tape and so forth. So let's go ahead and load a tape. We have to close this door on top here because it's using an airstream, so we have to maintain the aerodynamics. And what I'm going to do is I'm just going to use small tape. You can use either a small tape like this or a big one, but we're going to do some self-tests where it actually reads and writes the tape, so just so that's shorter. So what we would do is just stick the tape in there. We don't have to do anything with the tape or anything, but we can see a little bit's fallen off. And what I'm going to do is when I close the door, it's going to start to load the tape, and you'll hear the blower spin up and start blowing air. So it's going to, what it's going to try and do is start blowing air on the tape to get the end of the tape here, and it's going to rewind it until the sensors can find the end of the tape. Then it's going to, through the airstream, start threading it along here. What I'm going to do is just move the camera up on top so we can just see that. So close the door. It's saying right now XE on, so that's compression. We don't want that, so just say forget that, and we want it to load that. And so what we're going to be able to see here is the tape being threaded. We see it's trying to find the end of the tape there. And spinning around again. There we go. Okay, it's going to try that once or twice. Okay, once the take-up reel starts spinning, you see it's going to thread the tape around here. And this is just from air blowing out from the blower down here. And once it gets it threaded on the take-up reel, it's going to start looking for the beginning of the tape. Okay, that's what it's doing. It's found the beginning of tape. It's going to position there, and then it's going to be ready. So what we have here is, we see on the front panel BOT, so that's beginning of tape, is set up there. The other thing that we can do, if it was connected to a system, we could press the online button up here, and it would tell the system that it's online. So actually, let's go ahead and do that. There we go. So one of the things that we're going to do, just to show the operation of the tape, one of the things that operators and CEs could do is run various tests and so forth. And this particular drive has not millions, but it has a ton of self-tests and diagnostics that it can run. And it does one when we first started up. What I'm going to do is, I have a test that actually will write a pattern to the tape and then read it back, just to confirm that happened correctly. So what I'm going to do is, I'm going to press the option button here, and it should tell us, the first thing is test. We can go through various different options. So press enter. So yes, we want to do a test, and it's going to ask us, what test do you want to do? Test 0, 1, 2. We want to do test 101. So we're going to hold that down until it gets to 101. 80, 90, 102, pretty good. 101. Okay, enter. How many times do we want to run it? Once, 10 times, 100 times, 1,000 times. Nope. Loop it forever? No. We're just going to run it once. Okay, and 6250 is the density of the tape versus 1600 BPI. We're just going to do that. Fail 101. Ah, okay. Error 4. So why is it giving us that error? So we're trying to invoke a test that's going to write to the tape and then read it back. So what this error is telling us is there's not a write ring in the tape. So what we have to do is hit reset, go back to the main menu. We're going to say unload the tape. It's going to unload it, open the drawer so we can take it out. We're going to put a write ring in the back of the tape. So let's do that. Let's insert this write ring right here. Put the tape back in. Nope, we don't care about compression. Load it. And usually at this point, if this was actually being used on a system, the operator would just hit online and then they just walk away because everything would be taken care of. The system would automatically recognize the tape if it was a labeled tape, meaning that the tape actually had some identifying information written on it magnetically on the actual tape. Then the system could recognize that. If it was unlabeled tape, it just assumes the operator mounted the correct tape, which could sometimes be a problem in a batch environment. Okay, so we're loading this tape. It's going to find the beginning of the tape, the BOT mark. We're going to say we want to do a test. I'm going to go through this really quickly here. So we're going to try and run test 101 again. 50, 60, 70, 80, 90, 100. Whoops. Okay, 101, run it once. 6250 for the density. Okay, run it. Okay, this time we have a write ring in, so it is actually running the test now and writing the pattern on the tape. And it's going to write this pattern on the entire tape, rewind it, read the tape again, and just confirm that the pattern it wrote on the tape is the one that it read off the tape. And then it will give us a failure or a success indicator. So, and that's why it's good to have. This is actually the shortest tape that I had. I might have been able to find a shorter one, but down here it's showing us how far it's gotten on the tape. So there's a segment display right down here. And it's saying the tape is, sorry, you probably can't see this. This little indicator light here is saying write enabled, what the density is that it's doing. Now it's rewinding the tape, and this actually, so these tape drives could read tapes backwards. In other words, if it had a big enough buffer, it could read the tape while it was going backwards, and then, you know, just transfer the data in order by when it copied the data from the tape drive to the actual system. So I actually don't know which of that it's doing. Okay, it looks like now it was just rewinding it, and now it's oh, okay, it did read it backwards. So instead of that being a rewind, it was actually reading it backwards while it was rewinding it. So we see down here that this test passed, and then that's done. So usually what would happen is if the tape was being used by a program or a job on the system, there'd be a command issued from your program saying, I'm done with the tape, go ahead and unload it. And what would happen is the tape would unload, the door would pop open, the operator would know, okay, this tape is, the program is done with this job, so I can take this tape out now and either mount the next tape or just close the door and wait until the next job needed the tape.